correctness checking and debugging, and this is the so-called MPI. I don't know if correctness checker is the correct name anymore. It could be that it is MPI message checker, but nevertheless it's the same tool. This feature is already there for, I would say, from the beginning of this millennium. So they try to implement a correctness checking library that is delivered together with the ITAC distribution. So the usage is quite the same as in ITAC. You just LD preload a library which uses the profiling interface of MPI, and it overloads every MPI call and then does some checking if the message passing works in a correct way. Let me say more about it later. So the correctness checker is checking for common MPI problems. So it checks the interfaces if the interface was used correctly, if it finds errors like wrong data types or so. That's very easy. But more interesting are things like deadlocks. So it's not checking for deadlocks that are really happening, but it also checks for potential deadlocks. There's an easy way to do this because everything is changed to this protocol where MPI send and MPI receive are truly blocking. And so you can find in your application even potential deadlocks. I was confronted with that when I began working for my previous company. That was Pallas was a small company that was delivering Vampire that days, and one of my first tasks was to change the DWD from the German weather forecast, the benchmark from Parmax to MPI. And this was quite involved in a lot of work, and I did the easy way and used only MPI send and MPI receive in a very naive way because it worked all on the Cray. But then we had to port this to an SP3 of IBM, and for the large benchmark it blocked. And then if I had this tool in that case, I would have immediately the position where everything was blocking. But this could be, of course, easily removed by using iSend and iReceive. But this is an easy way of finding a deadlock, but other things are more involved, and I would say the most involved problems you see in MPI programs is the request management. So if you have requests in MPI send, MPI iSend and MPI iReceive, and you do it not correctly, then the program might run and shows no errors besides probably wrong results, and it's very, very hard to find. And we had some customers who came back and reported that they found errors that were for a very long time in their code and they never found before. But this tool was directly pointing them to unfinished requests, and that could be fixed then. MPI correctness checking, there is the fail-safe mode. Fail-safe mode is used of MPI. That is that for the Intel MPI that you have a special implementation that tries to get a trace file even when the application crashes. That's using communication that is independent of the MPI communication to really finish the ITAC in the end and get a trace file even if the application is crashing. And this is not shown because I will only go on the MPI part, but then you would go for inspector to check for memory problems or for threading problems. So the thread checking in inspector is really recommendable. If you haven't heard of it, then this is a tool to really find problems in threading, in threaded code. This would be the typical situation that I faced here with my port there of the DWD code, or how you can generate a deadlock in MPI. So both sides, both ranks here issue an MPI send, and they can only proceed if they get the matching MPI receive from the other side. So if you do this pattern and have large enough messages, then it will truly block. But it may or may not block, because in the implementation it depends on if it's probably for small messages, a buffered send, then it will work. But if the protocol switches from a certain message size, then it will block. This situation would be caught easily by our tool, and and it will directly point you to this to this pattern. And if you compile with -G, it will even show you the source code line for this. So this is very handy. Another thing would be something like memory reused in a forbidden way. So for example, you have define a message buffer, use an MPI send, and then you redefine the message buffer before without having an MPI wait or MPI test to finish the ISend and give the message buffer free again. So this situation would be also found by the by the message checker. So correctness checking would work like this. You have, well, I think I don't need to tell too much about it. So we have over 15 distinct programming errors and runtime errors are found. Issues with data types, buffers, communicators, point-to-point messages, collective operations, and last not least, deadlocks. What's nice is that it checks, generates a checksum before each send and after each receive, and compares it. So when there is some corruption in your network that's probably independent of your MPI code, then you can find this here with this checking of the message checksums. And you either have the report directly on command line when it runs, so you just run it and it prints you in standard out the errors or warnings if it finds it, or you can generate a trace file. For the trace file, you have to set one option, one environment variable. Then it prints a trace file, and the trace file looks similar to Vampire or to ITAC, but you have, for each error, you have then a symbol and can click on the symbol to get more information. It's even possible to trigger breakpoints for the position where the errors happen, so that you can use these breakpoints inside a debugger to directly go with the debugger to that position in your code where you have to fix something. Availability, so it's packaged with the Intel Trace Analyzer and Collector ITEC and for use with Intel MPI. But since the binary interface now it's quite similar, I would say that there's a good chance that it works with Cray MPI as well. So I should give it a try and find out if it's really applicable for Cray MPI. Otherwise, this is not performance critical, and if you have a compatibility mode, even if it runs slower, then you get the information here with Intel MPI. Oh, sorry, I had the same. Oh, sorry. Yeah, for some magic, it's just changing here between my laptop and the projector. And here are two customer statements. Frankly, they are quite old, but nevertheless, it's they are still important. So here, people from LS Diner found a long-lasting error that they never thought about before, and that's probably happening every once in a while. And with this tool, they were directly pointed to it. Probably it was request management, and the same here for EMSS that they had. I think it was as well a request management problem that was detected by message checker. Yeah, and you can probably, when you develop, run it the first time with the message checker, just to be get more confidence that your program is running correctly and not a predefined error is found in your program. And probably it's because the procedure is very easy that you can just preload the library. You can do this once in a while during your development to find if it's still working correctly. Yeah, here it's written that the objectives would be either finding programming errors, but also by having these checksums, if there are problems in the network, if your network is not running correctly, then you might find errors by using the checksums, which is done automatically. And you have the automatic detection of errors. So either you have the print on the standard out, or you generate the trace files, and then you have some, for each error you have a bullet that shows you, gives you more information. Please see the next, one of the next slides. This is how to use it. So the check MPI is, of course, the minus check MPI is, of course, only for Intel MPI. It's integrated into MPI run. But nevertheless, what check MPI does under the hood is to set the environment variable LD preload equals lib vtmc.so. And you just preload this library, and by the profiling mechanism of MPI, it's preloaded as a wrapper to each MPI function and does the checking. And here with Intel MPI, you can use it as a command line environment variable, but if you don't want to touch your scripts or your command line, you can just export the preload variable. So this is in some situation very handy where it's not possible to touch the command line, or when you're dealing with complicated scripts where you don't know which path is actually taken. Or you can even link this statically with libvtmc. Probably depends on the, should work. At best, you should also use, during compilation, the -G flag to get the debugging symbols and to see the source line in the output. This is how it looks like in the standard output with -check MPI. And you see it is issuing warnings, and here it's a memory overlap, so probably a buffer is reused before having an MPI wait on that buffer. And it will point you to the active buffer control was transferred to MPI in MPI send. And here you get the correct source line, here overlap.c 104. And then the buffer is reused, or the buffer is reused later in another MPI send in overlap 105. So it wasn't correctly, the request wasn't correctly ended by an MPI wait, and this can be crucial to spoil. It's even not, even if the buffer is the same and you only send it. So you might ask what happens in between with the buffer, because it's not touched by the user, but it's forbidden by the standard that you reuse the buffer before it is finished with an MPI wait. So you need to issue an MPI wait, or it will it's just issuing a warning. But if you are strict, it could be the implementation under the hood could change the buffer in between, and that would spoil the whole thing. So you need to use an MPI wait here in between. Hans, your battery is low again. So that would be how the trace file looks like, and looks like an ITEC trace. And here for each process you see a bar, but instead of you see also the MPI calls, but additionally you see some bullets. Think yellow bullets for warnings and black bullets for errors. And then you can click on these bullets and get more information, like information about the kind of error, where it happens, and other stuff, and you can click on it. If you have enabled the source view, then you can directly go to the source of this function. This is very handy, but for the trace file, you need to specify an environment variable to get really the trace file. Otherwise, you will see only output of on the standard out. So this is the correctness checker. Was there something? Do you have additional questions to that tool?
I have.
Yep.
So I've been using it in the correctness checking in the past. I find it very nice because indeed he found out when one of my buffer went outside of scope while still in MPI. I was wondering how much, or how can we use it on our KNL machine?
I would say the best would be either the LD preload, if you have a dynamic linking in your program, or probably the static linking. In earlier days, it was necessary to have the right order of the linked libraries to really ensure that the wrapper is at the right place.
And when we start the MPI run, we have to put the check MPI because this is Intel MPI, I guess.
This is only working with Intel MPI, so it's integrated into the Intel MPI run command.
But you will do the same then?
But the -genv would be more flexible, I would say. If you, or not -g, the export of the LD preload is more flexible.
And if you work also with Cray and pitch, or Cray MPI?
I cannot promise. I haven't tried it, but I see a good chance that it works.
So it's on our side then to test and report to Cray then?
Yeah, probably I can try it today.
Yeah.
So yesterday, just a side information, yesterday I tried to use the advisor here and it works. But the only thing is that you have to use the shared, the dynamic linking of Cray, and you have to use another file system, not the home file system, but the scratch file system, but because it's somehow it's not working with the Cray file system.
But that's what the user are expected to use, actually.
Yeah. And maybe colleagues are working on making it available for the Cray compiler as well. So that is only a minor change, and we're already testing it on the Stuttgart machine.
And regarding Intel MPI, is it using libfabric, or will you use libfabric internally? Then maybe that we could use it on our Cray system.
Yes, the OFI interface is using the libfabric, and you can point to it. So probably that is working. Yep. Okay, then let's have a break now.